Black holes. The most mysterious things in the universe. These beasts are among the most fascinating objects in space. Black holes are among the strangest and most fascinating objects in the universe. They're so dense and have such a strong gravitational pull that not even light can escape their grasp. The Milky Way may contain more than 100 million black holes, though detecting these ravenous beasts is extremely difficult. Sagittarius A is a supermassive black hole at the center of the Milky Way. According to NASA, the massive structure is approximately 4 million times the mass of the Sun and is located approximately 26,000 light-years away from Earth. The Event Horizon Telescope collaboration captured the first image of a black hole in 2019. The stunning image of the black hole at the center of the M87 galaxy, 55 million light-years from Earth, wowed scientists worldwide. With his general theory of relativity, Albert Einstein predicted the existence of black holes for the first time in 1916. Many years later, in 1967, American astronomer John Wheeler coined the term black hole. After decades of only knowing black holes as theoretical objects, Cygnus X1, the first black hole discovered, is located within the Milky Way in the constellation of Cygnus, the Swan. According to NASA, the first signs of a black hole were discovered in 1964 when a sounding rocket detected celestial sources of X-rays. Astronomers discovered that the X-rays were coming from a bright blue star orbiting a strange dark object in 1971. The detected X-rays were thought to be the result of stellar material being stripped away from the bright star and gobbled up by the dark object, an all-consuming black hole. How many black holes are there? According to the Space Telescope Science Institute, 1 out of every 1,000 stars is massive enough to become a black hole. Because the Milky Way contains more than 100 billion stars, our home galaxy must contain 100 million black holes. Though detecting black holes is difficult, NASA estimates that there could be up to 1 billion stellar black holes in the Milky Way. The closest black hole to Earth is known as the Unicorn, and it is located about 1,500 light-years away. The nickname has two meanings. The black hole candidate not only lives in the constellation Monoceros, the Unicorn, but its incredibly low mass, which is about 3 times that of the Sun, makes it nearly unique. What do black holes look like? The outer and inner event horizons, as well as the singularity, are the 3 layers of a black hole. A black hole's event horizon is the boundary around its mouth beyond which light cannot escape. A particle cannot leave once it has crossed the event horizon. Across the event horizon, gravity remains constant. The inner region of a black hole, where the object's mass is concentrated, is known as its singularity, which is the single point in spacetime where the black hole's mass is concentrated. Scientists cannot see black holes in the same way that they can see stars and other celestial objects. Astronomers must instead rely on detecting the radiation emitted by black holes as dust and gas are drawn into the dense creatures. However, supermassive black holes in the center of a galaxy may become shrouded by the thick dust and gas that surrounds them, blocking the telltale emissions. When matter is drawn toward a black hole, it can ricochet off the event horizon and be thrown outward instead of being dragged into the maw. Bright jets of material at near relativistic speeds are produced. Although the black hole cannot be seen, these powerful jets can be seen from a long distance. The EHT's image of a black hole in M87 required 2 years of research even after the images were taken. Because the collaboration of telescopes, which spans many observatories around the world, generates an astounding amount of data that is too large to transfer over the Internet. Researchers hope to image other black holes in the future and create a database of what the objects look like. The next target will most likely be Sagittarius A, the black hole at the heart of our own Milky Way galaxy. According to a 2019 study, Sagittarius A is intriguing because it is quieter than expected, which could be due to magnetic fields suffocating its activity. Another study that year discovered a cool gas halo surrounding Sagittarius A, providing unprecedented insight into the environment surrounding a black hole. Types of black holes. Astronomers have discovered 3 types of black holes so far. They are stellar black holes, supermassive black holes, and intermediate black holes. Stellar black holes. When a star depletes its fuel, the object may collapse or fall into itself. The new core of a smaller star will become a neutron star or a white dwarf. When a larger star collapses, however, it continues to compress, resulting in the formation of a stellar black hole. Individual star collapse produces black holes that are relatively small but extremely dense. One of these objects can fit more than 3 times the mass of the Sun into a city the size of Manhattan. This causes a tremendous amount of gravitational force to be exerted on objects surrounding the object. Stellar black holes then consume the dust and gas from their surrounding galaxies, causing them to expand in size. Supermassive black holes. Small black holes abound in the universe, but their cousins, supermassive black holes, rule the roost. These massive black holes are millions, if not billions, of times the mass of the Sun, but have roughly the same diameter. Such black holes are thought to exist at the heart of almost every galaxy, including our own. Scientists aren't sure how such massive black holes form. Once formed, these giants gather mass from the dust and gas around them, which is abundant in the centers of galaxies, allowing them to grow to even larger sizes. Hundreds or thousands of tiny black holes may merge to form supermassive black holes. Large gas clouds could also be to blame, collapsing and rapidly accumulating mass. A third possibility is the collapse of a stellar cluster, which is a group of stars that all fall together. Fourth, supermassive black holes could form from dense concentrations of dark matter. We can see dark matter because of its gravitational effect on other objects. However, we don't know what it's made of because it doesn't emit light and cannot be directly observed. Intermediate black holes. Scientists used to believe that black holes only came in small and large sizes, but new research suggests that mid-size, or intermediate, black holes may exist. Such bodies could form as a result of a chain reaction between stars in a cluster. Several of these intermediate black holes that form in the same region could eventually collide in the center of a galaxy to form a supermassive black hole. Astronomers discovered what appeared to be an intermediate mass black hole in the arm of a spiral galaxy in 2014. In 2021, astronomers used an ancient gamma-ray burst to detect one. Astronomers have been searching for these medium-sized black holes for a very long time. Study co-author Tim Roberts of the University of Durham in the United Kingdom said in a statement. There have been hints that they exist, but intermediate black holes have acted like a long-lost relative who doesn't want to be found. According to 2018 research, these intermediate black holes may exist in the cores of dwarf galaxies. Observations of 10 such galaxies revealed X-ray activity, which is common in black holes, indicating the presence of black holes ranging in mass from 36,000 to 316,000 solar masses. The data came from the Sloan Digital Sky Survey, which examines approximately 1 million galaxies and can detect the type of light that is frequently observed coming from black holes that are picking up nearby debris. Binary black holes. Using the Laser Interferometer Gravitational Wave Observatory, astronomers detected gravitational waves from merging stellar black holes in 2015. We have more confirmation of the existence of stellar mass black holes larger than 20 solar masses. These are objects we didn't know existed before Laser Interferometer Gravitational Wave Observatory detected them, said David Shoemaker, the Laser Interferometer Gravitational Wave Observatory Scientific Collaboration spokesperson. Laser Interferometer Gravitational Wave Observatory observations also provide information about the spin direction of a black hole. When two black holes spiral around each other, they can spin in the same or opposite directions. There are two theories about the formation of binary black holes. The first postulates that the two black holes formed in a binary form around the same time, from two stars that were born together and died explosively around the same time. The companion stars would have shared the same spin orientation, as would the two black holes left behind. According to the second model, black holes in a stellar cluster sink to the cluster's center and pair up. According to the Laser Interferometer Gravitational Wave Observatory scientific collaboration, these companions would have random spin orientations when compared to one another. Laser Interferometer Gravitational Wave Observatory observations of companion black holes with different spin orientations lend support to this theory. Black hole facts. Number 1. Theory has long suggested that if you fell into a black hole, gravity would stretch you out like spaghetti, though you would die before reaching the singularity. However, according to a 2012 study published in the journal Nature, quantum effects would cause the event horizon to behave similarly to a wall of fire, instantly burning you to death. Number 2. Black holes aren't bad. Suction occurs when something is drawn into a vacuum, which the massive black hole is not. Rather, objects fall into them in the same way that they fall toward anything that has gravity, such as the Earth. Number 3. Cygnus X1 was the first object identified as a black hole. Stephen Hawking and fellow physicist Kip Thorne bet on Cygnus X1 in a friendly wager in 1974, with Hawking betting that the source was not a black hole. Hawking conceded defeat in 1990. Number 4. Miniature black holes could have formed right after the Big Bang. Some regions of rapidly expanding space may have been squeezed into tiny, dense black holes less massive than the Sun. Number 5. If a star comes too close to a black hole, it can be ripped apart. Number 6. Astronomers believe the Milky Way contains between 10 million and 1 billion stellar black holes, each with a mass roughly 3 times that of the Sun. Number 7. Black holes continue to be fantastic fodder for science fiction novels and films. Examine the film, Interstellar, which heavily relied on Thorne to incorporate science. Thorne's collaboration with the film's special effects team improved scientists' understanding of how distant stars might appear when viewed near a rapidly spinning black hole. That is all for black holes, the most mysterious things in the universe. Let us know what you think in the comments. Thanks for watching, and don't forget to subscribe so you won't miss any future videos.